Could a common painkiller really be part of the problem? Could Tylenol really cause autism? Is that what I heard? Or is it just hype? Hi, everyone, and thank you for tuning in to our It's a Kids World vlog. Because of the press conference we all saw recently, I started thinking about something that's been quietly sitting in the background of a much bigger conversation. Could something as common as ordinary as acetaminophen, the painkiller reliever most of us have in our cabinets, actually be part of the neurological problem we're all trying to understand? Please listen through for some interesting studies and, of course, more thought-provoking questions, and leave a comment or two down below. And hey, if you use a product with acetaminophen in it, leave a yes in the comments or a no if you don't. Would like to know what your thoughts are. And before we go any further, I want to make something crystal clear. I'm not a doctor. Neither is Dawn. We're parents and grandparents. We're people who have spent years reading the research, asking the questions, and trying to connect the dots. Not because we wanted to, but because we had to. And what I'm sharing here isn't medical advice, it's our perspective, based on publicly available, peer-reviewed research. And you should always consult a qualified medical professional about your own health decisions. So, if something so ordinary is even possibly connected to rising rates of neurological disorders, why aren't more people talking about it? And what does the science show? Let's start with the big picture. The numbers alone are worth pausing for. Back in 2000, the CDC estimated that about 1 in 150 8-year-old children in the U.S. had been diagnosed with autism spectrum disorder. By 2020, that number was 1 in 36, and the latest CDC network report from 2025 puts it at roughly 1 in 31. That's not just a small uptick, that's a seismic shift in a single generation. And it's not only autism. According to the CDC, about 6.1 million U.S. children had been diagnosed with ADHD by 2016, and those numbers have continued to rise. Think about that. In just 2 decades, we've gone from a condition most people rarely encountered to one almost every family knows personally. So what changed? Genetics don't shift that quickly. Something else, or many somethings, are interacting with biology in ways we don't fully understand. That is why scientists are exploring possible environmental, dietary, and chemical contributors. And one of those things, surprisingly, is acetaminophen, the active ingredient in Tylenol and dozens of other over-the-counter medications. Let's look at what the science actually says. A large study in 2014 in JAMA Pediatrics followed more than 64,000 mothers and their children in Denmark. It found that prenatal exposure to acetaminophen was associated with a significantly higher risk of ADHD and autism in children. Those findings were echoed in a 2021 meta-analysis that reviewed data from over 70,000 mother-child pairs across multiple countries. The authors found a consistent association between prenatal acetaminophen use and an increased risk of both ADHD and ASD. Now, association isn't causation, but when several large studies keep pointing in the same direction, isn't that worth digging deeper? For Dawn, who was diagnosed ADHD at age 5, and I, who have dyslexia, this isn't just data on a screen, this is personal. When Dawn was pregnant, doctors, like they do for millions of parents, recommended acetaminophen for pain or fever. She trusted that advice. She also gave it to her children when they were sick, believing it was the safest choice. And just like countless families, she did it because she cared. Today, 2 of her children show neurological symptoms that mirror those described in the research. And that's why this topic matters so much to us. because we're not talking about rare chemicals or exotic toxins. We're talking about something every household uses. So let's talk about how this might actually work inside the body. When your liver breaks down acetaminophen, it produces a toxic byproduct called NAPQI, NAPQI, short for N-acetyl P-benzoquinoamine. Under normal conditions, NAPQI is quickly neutralized by one of the most important molecules in your body, glutathione. So, myth or fact, antioxidants are something you only get from diet. Fact, your body makes its most important, its most powerful antioxidant, and it's called glutathione. It's your body's frontline defense against oxidative stress, which is the imbalance that happens when damaging molecules called free radicals outnumber your antioxidants that neutralize them. It's vital for detoxifying heavy metals, neutralizing reactive oxygen species, and protecting that delicate brain tissue from damage. Here's the problem. Acetaminophen burns through glutathione. If the body doesn't have enough glutathione available, NAPQI starts binding to cellular proteins and damaging them. This process is well documented. It's the same mechanism behind acetaminophen overdose and liver failure. But here's where it gets even more interesting. Research shows that children with autism consistently have lower glutathione levels than neurotypical children, and when glutathione levels are depleted, oxidative stress goes up significantly. Has what you've heard so far changed your view of acetaminophen? Put a 1 in the comments for yes or a 2 for no. And could that information mean that some children, especially those with lower antioxidant capacity, are they more vulnerable to the effects of acetaminophen? Let me put this into a real-life context again. Dawn and I had no idea how important glutathione was. Dawn recalls when her children were little, she gave them acetaminophen for everything from fevers to teething pain. She thought it was doing the right thing, and she was, based on the information she had. But no one ever mentioned what repeated use might do to their antioxidant defenses or how oxidative stress could affect a developing brain. This isn't about blame, it's about connecting the dots between biochemical mechanisms and the rising tide of neurological disorders. What does the science show us here? Oxidative stress isn't some fringe concept. It's one of the most widely studied factors in neurodevelopmental and neurodegenerative conditions. Multiple studies show elevated oxidative stress markers in individuals with autism. This was a study by Chuhan and Chuhan, published in Pathophysiology back in 2006. And Dr. Joseph and his team published a study in Neurochemistry International in 2015 on ADHD showing elevated oxidative stress, and in 2013 Dr. Butterfield and his team even showed this in Alzheimer's patients in a study in free radical and biological medicine. So in one meta-analysis, oxidative stress biomarkers were significantly higher in children with ASD compared to controls, and their antioxidant capacity, including glutathione levels, was significantly lower. So if glutathione's already low in many kids with autism and acetaminophen further depletes it, couldn't that be a dangerous combination? Not because acetaminophen causes autism, but because it might tip the balance in a system that's already under excessive oxidative stress. So, knowing what the science tells us, that glutathione is critical, that oxidative stress is linked to neurological challenges, and that acetaminophen can drain our antioxidant defenses, the natural question is, what can we do about it? One approach that's been studied is N-acetylcysteine, or NAC. NAC is a precursor to glutathione. Basically, it gives your body the raw cysteine it needs to make more glutathione. Several clinical trials and meta-analysis shows that NAC supplementation can raise glutathione levels, and it reduces oxidative stress. Dr. Dean and his team published a study in CNS drugs in 2011. But here's the part most people don't realize. Fact or myth? If you take a supplement, it all gets absorbed. No. The fact is that many compounds, including NAC, are only partially absorbed and require careful dosing to be effective. NAC's oral bioavailability, that is how much it is actually reaching your bloodstream, is actually relatively low. Typically it's around 6 to 10%. And its half-life, the length of time it stays in your system, is short. It's about 5.5 hours. That means it leaves the body quickly and usually needs to be taken in divided doses to keep levels steady. Another option that's been studied, and the one that we personally use, is called Immunocal. This is a specially processed whey protein that's rich in cysteine, the key building block that your body uses to make glutathione. And clinical studies have shown that Immunocal can significantly raise glutathione levels in humans. We choose Immunocal for our family because of the published science. But, and I can't stress this enough, we always suggest digging deeper and doing your own research, and of course, talk to your healthcare professional before starting anything new. I encourage you to comment and ask us your questions, and I'll drop a link down below. Besides our own experiences, we're part of a very diverse team of great people, one of whom has recovered from traumatic brain injury from severe electrical shocks. Now, later on, we're going to have another one of these vlogs with Dr. Jimmy Gutman. He's Immunotech CMO, and we're going to do a dive into some of the specific scientific studies that have been done pertaining directly to neurodevelopmental conditions and glutathione and Immunocal. And I know what you're going to ask. You're going to say, hey, these kids, they can't handle whey protein. That's one of the questions we're going to ask Dr. Gutman. So, summarizing the scientific evidence, acetaminophen use can deplete glutathione. Low glutathione means more oxidative stress, and oxidative stress is consistently linked to neurodevelopmental conditions. NAC and Immunocal are two tools that researchers have studied to support glutathione, but they're not magic bullets, and more research is needed. Now, here's the thing. Dawn and I didn't make this video to tell anyone what to do. We're not doctors. We're just two grandparents who trusted the system, followed the advice we were given, and now find ourselves looking back and wondering if some of those decisions may have played a part in the challenges that our family faces today. We share this because we believe knowledge is power. If even one parent watching this video decides to read the studies, ask the questions, and make a more informed decision for their family, isn't that worth it? If the data keeps pointing to the same biochemical pathway, shouldn't we be studying it with everything we've got? Let's be clear about what the science says so far. Neurological conditions like autism and ADHD are rising sharply. Prenatal and early life acetaminophen use is consistently associated with increased risk, according to multiple studies across the world. Acetaminophen depletes glutathione and increasing oxidative stress. Oxidative stress and low antioxidant capacity are documented in children with autism. But there are strategies to support glutathione. But, of course, more independent, large-scale research is really needed. Again, it's not about blame. It's about progress. It's about demanding more science, more honesty, and more transparency about how everyday exposures interact with developing brains. And speaking of exposures, acetaminophen is just one piece of the puzzle. In our next episode, we're diving into one of the most potent and pervasive neurotoxins humanity has ever encountered: mercury. From dental fillings and seafood to industrial emissions, it's still around us, and Dawn's own story with mercury toxicity shows just how real its impact can be. Until then, I encourage you to look up the studies we mentioned. They're posted below. Talk with your healthcare team and ask questions. Keep asking questions. Because when it comes to our children's brains and our own, those questions matter. And remember, every child is a gift. Thank you and good night.